Okay, imagine this. You're working on like a seriously hard math problem, the kind that just makes your head spin, right? But instead of grabbing a calculator with the textbook, you just pull out your phone. And with the help of, well, a small but mighty AI, you break down the problem step by step, just like, a total math whiz. And that's exactly the kind of incredible potential we're talking about today. With rStar-Math, this system is really changing how we think about, well, AI and how it solves problems. It's all about giving these smaller AI models the ability to, like, think deeply. And I mean, not just spitting out answers, but actually understanding how to reason through a problem. Like, the difference between thinking quickly on your feet versus that really methodical step-by-step way you solve a puzzle. That's what we're talking about. So traditional large language models, they often try to solve math problems in one shot, relying on a kind of, well, mental shortcut. But that can lead to errors, especially when things get super complicated. But rStar-Math, it takes a different approach. It uses something called Monte Carlo Tree Search, or MCTS. And picture this. The AI gets a map with different paths, each one a different reasoning step. It explores these paths, checks out how good each step is, and then learns from, well, any wrong turns it makes. It's not just randomly guessing. It's really strategically looking for the absolute best solution. And to guide this exploration, rStar-Math has this secret weapon. It's called the Process Preference Model, or PPM. And it's kind of like a built-in tutor, helping the AI tell the difference between steps that are looking good and ones that might not be so great, just like you might learn from watching a pro solve a problem. But here's where it gets even cooler. rStar-Math actually gets better over time. It goes through these 4 rounds of self-evolution. And with each round, its reasoning skills get sharper. So it's not stuck with just what it starts with. It's always learning and growing, just like we do. But how do we know it's not just making stuff up? Math needs to be precise. And that's where another super smart part of rStar-Math comes in. It uses code execution to double-check every single step of its reasoning, like having a fact checker built right in, making sure everything makes sense and is totally logical. So by actually running the code at each step, rStar-Math can catch mistakes really early, which means way better solutions compared to approaches that just check the final answer. It's like a safety net that lets you try different things without worrying about making a big mistake. That could really mess things up. So now you might be thinking, all right, this is all super impressive, but this kind of advanced AI needs a ton of power, right? Like something you'd only find at those, huge tech companies or labs. But, and this is really cool, the people behind rStar-Math had a completely different idea. They wanted to make something that could maybe even run on, well, something as simple as your phone. Yeah, think about it. Your phone is a math genius right in your pocket. And this is because rStar-Math challenges that whole idea that bigger is always better with AI. It shows us that even smaller, more focused models, when they use techniques like, that MCTS we talked about, they can actually beat those giant energy-hungry models, at least for certain tasks. Having a whole team of math experts, each one a specialist in their own area, instead of one generalist who might not be as good at any one thing. So we might not always need to keep making these bigger and bigger AI models to get big improvements. Instead, we can, well, make them smarter and more efficient, which could mean AI that's not just more powerful, but also more sustainable, more accessible, and even personalized. Imagine having an AI math tutor that adapts to how you learn and helps you get concepts in your own speed. And it all comes back to rStar-Math being this deep thinking AI. It's not just finding an answer. It's about understanding how to get there. rStar-Math isn't just spitting out an answer. It's giving you a step-by-step breakdown, almost like a human mathematician showing their work. So you're not just getting the answer, but you're seeing how it got there. Like having an AI that can solve the problem and explain its thought process. So you can learn along the way, right? And let's talk about this idea of rStar-Math being self-evolved. Yeah, I know it sounds a bit sci-fi, but it's actually pretty elegant. It starts with a basic model, and then through these rounds, it uses its own reasoning to make and check harder and harder math problems. It's like a student who goes from basic textbooks to tackling tough research papers. And with each round, rStar-Math gets sharper. It can handle a wider range of, well, math challenges, almost like it's pulling itself up by its bootstraps, right? And the really remarkable thing is that this self-evolution, it's driven by the AI's own internal feedback. It doesn't need humans to tell it what's right or wrong. It has things built in, like that process preference model that act like its own internal critics. They check how good each step in its reasoning is and help it find better solutions, always pushing rStar-Math to get better, having a built-in quality control system that's constantly making its own thinking better. So Star-Math isn't just copying human problem solving, it's developing its own ways of thinking. And that's one of the most exciting things about this research. It shows us that AI might not just copy human intelligence, but maybe even go beyond it in some ways. Now, I know you might be thinking, are we about to have an AI math overlord? But remember, this is still early research. However, it's clear that rStar-Math is changing what we thought was possible with AI. And it makes us ask some really big questions about what intelligence really is. Questions like, what does it mean to actually think? Can machines really understand things the way we do? And if they can, what does that mean for us in a world where AI is getting so good at solving complex problems? These are questions that, well, philosophers and scientists have been thinking about for a long time, and Star-Math just adds a whole new layer to that discussion.